Welcome to lecture 10 part 2. So I believe the best thing to do before doing a lot more examples is to summarize what we already did in class. Okay, so let me write things down here. So when you are given a function that is a transformation of another function and you are asked to draw it. So this is the steps you need to follow. So the first step is you need to identify what the parent function is, and in this case the parent function is x squared. So first step is determine the parent function. And once you identify the parent function, you need to see one by one what transformation do we have to do in order to get the last function. So let me just write it down, and you will need to follow a certain order. Now sometimes in some cases some orders doesn't matter as long as you do the vertical shifts last, but sometimes some orders might be easier. So let's, for this class, let's keep an order of doing the transformations. So let me just write it down. So start with the parent function. Function, that's my short notation for function, and do a series of transformations one at a time. Do a series of transformations one at a time. Now that's very important because that would determine, well, sometimes you might have to do a series that would be like 5 terms, but still you have to do it one at a time. So one transformation at a time in the following order. Now right now we have learned a set of transformations. So the order that I would follow, or I would want you to follow, is the first one is reflections. So reflections with respect to x-axis or y-axis, any kind of reflection. The second one is horizontal shifts. So denote reflections, I would do that, horizontal shifts. And then 3 is any type of compression or stretch. So either horizontal or vertical compression or stretch. Now so this one you can do sometimes if it combines a horizontal compression with a vertical stretch. You can do it in either order you wish, okay, and hopefully it might not make a difference. And the last thing you have to do is the vertical translation or vertical shifts. So either like that. Now when you do this, you need to keep track of one of those important points. Now in some classes we will do 2 important points, but right now I just want you to do, let's do one of those important points and keep track of that important point. So keep track of what happens to an important point. Now that is a very vague thing, important point on a graph, on the graph. But you can sort of understand it. Let's say if we are doing a parabola, the important point would be the vertex. So keep track of how the vertex moves when you do all those transformations. So let's do this example and see how we use this. Okay, so it's R H reflections, horizontal shifts, horizontal vertical compression or stretch, and then lastly vertical shifts. So let's find the parent function. Well, the parent function, as you can clearly see, is x squared. Okay, now let's do a set of transformations. So there are no reflections, there are no negative signs in front of x or in front of the function. So the second one is horizontal shifts. Well, do we have horizontal shifts? Yes. And the horizontal shift would be x minus 3 squared. So minus means you move 3 to the right. Right 3. Okay. And also let's keep track of the point. Now x squared is the parabola. Okay. And let me just like draw a teeny tiny parabola here, and you have the point 0, 0 here. Now when you move 0, 0, 3 units to the right, you would add 3 to the x values. Now this acts, it doesn't act the way you want it to be. So you see here you have a negative. When you have it that way, you are adding. So if you just remember this by algebra, it might be very confusing. So always try to remember graphing by how the pictures move. Okay, so when it moves 3 units to the right, you would add 3. So you would get 0 plus 3, and the y value doesn't change, so that would be 3, 0. Okay. Okay, and that's the first transformation. And the second transformation is you subtract 2 right here. That's a vertical shift, and that's one we should do last. So x minus 3 squared minus 2, that's 2 down. Okay, and when the graph, now this graph right here would be you moved it 3 units to the right, so 3 here and that, and it moves 3 down, so you get that, and that point would be 3, negative 2. How do you get that? Algebraically you would subtract 2 from this point. So the point is 3, 0. You would do 3, 0 minus 2, which is 3, negative 2. So this point should be on the final graph. So the graph looks like a parabola which is open upwards and starting at the point 3, negative 2. Not starting, it's a vertex at the point 3, negative 2. So with that, we can actually draw the final graph. So on a scratch paper on a side, just do the series of transformations, and when it comes to drawing the graph, just draw it on the plot. So right here, what I have here is starting from 3, negative 2. That's the point 3, negative 2. I will always just make it a point that I have that point 3, negative 2, and then you just draw the parabola. Now some of the questions you might have is, can you find these points? Can you find these intercepts? Well, yes you can, but the point of this question is drawing using the transformations, and that doesn't matter for these questions. So of course you can find them, just set it equal to 0. It should be 3 plus root 2 and 3 minus root 2. So this one is 3 plus root 2 and this one is 3 minus root 2. But for this lesson, it is not as important as the example. Okay, so let's move on. So it's very important for us to understand this series of transformations. So the next one is, let's forget about the content of the function. Let's see how do we do it for any type of functions. All right. So let's see how we do this series of transformations to any type of functions, and this, the parent function is just fx. So the parent function is fx, and let me just recall what the transformation, the order of the transformation. 1, reflections. 2, horizontal shift. 3, compression, stretch, vertical or horizontal. 4, vertical shift. Okay, so that's the way you have to go. So let's see. Fx, there are no reflections, I can do a horizontal shift, and that would be x plus 1. So that would be my second transformation. And x plus 1, remember, let me just write down what we did. So f of x plus c, that's c left. F of x minus c, c right. F of x plus c on the outside, c up. F of x minus c, c down. And f of negative x, that's reflection with respect to y-axis, and negative fx, that would be negative sign outside, that would be reflection with respect to x-axis. Okay, so these are the things we discussed in class. Okay, so let me just go back to our sequence. So start with fx, go to f of x plus 1, and that's shift left by 1. Okay, that's okay. And then minus 2, so f of x plus 1 minus 2, that would be shift down by 2. So when it's outside, it's very obvious which way we are moving. When it's inside, you need to know how it moves. X plus 1 moves to the left, x minus 1 moves to the right. So these are the set of transformation. So you shift left by 1, shift down by 2. So let me just write down what the final answer is. Shift left by 1 and shift down by 2. Okay, so so let's see how we do the next one. Again, remember, and let me just write down the reflection f of cx. It's if c is bigger than 1, it's horizontal compression. F of cx, let's say f of 1 over cx, is that, if that's how I did in class, f of 1 over cx. Now both case c is bigger than 1, so that would be horizontal stretch. C of fx would be a vertical stretch, and 1 over c of fx, vertical compression. So those are all the transformations we did in class. I might have done this 1 over c, probably I might have said c and then c less than 1. Either way, that's the set of transformations. So let's see how we can do this. So let's start. Reflections, well, there's a reflection here, so we start from fx, but we reflect so that I get negative fx. See, I did not do -2 because I'm doing it one at a time. Okay, and then I would do negative f of x plus 1 because next one would be horizontal shifts. Okay, and then I would do -2 fx plus 1, and last I would do -2 fx plus 1 plus 2, which is the same as this is the same as 2 minus f2 fx plus 1. Okay, so that's what you needed. So that's the final function. So let us do the set of transformations. Now this is reflection with respect to x-axis. Okay, and then plus 1, that's a shift left by 1, and then multiply by 2, that would be a vertical stretch by 2. And lastly, this is up to. So the order of transformations is reflect with respect to x-axis, 2, shift left by 1, and vertical stretch by factor of 2, and lastly up 2. So we have 2 more examples to do, and these 2 examples are actually a little involved. So let's see. Okay, now I need you to have this by your side. So let me just have my summary on a side like this. Okay, so we can use it whenever I need it. So let's start with fx. So we start with fx, and I see a minus here, so let's do f of minus x. Now you have to be very careful when you do it. Okay, so my trick to avoid any of those mistakes would be just put a parenthesis right here. So I would say this is the safe bracket. So if I don't put my safe bracket, I would end up with the correct with the wrong transformation. So this, let me draw this in green, and let's call it the safe bracket. I mean, I could have called it the safe parenthesis, but safe bracket sounds much better. All right, so now you can see, well, if you are to put something in here that should give you +2, you need to put a -2 here. Okay, so let's write it down. So f negative and then safe bracket x minus 2. Okay, and this is the same as f negative x plus 2, which is the same as f of 2 minus x. Now you see, I got what I needed. So okay, so let's and then the last transformation would be down one. So um, f of you can write this because it's the same thing. So I would just write it f of 2 minus x minus 1. Okay, now because of the safe bracket you got things right. Okay, and you can also think what these movements are. Now this movement is a reflection with respect to y-axis. Reflection with respect to y-axis. Okay, and this, now it's x minus 2. Now you know what it is. It's x minus. So it's c 2 units to the right. Okay, and then that's one down. Okay, so that's that. So let me just write down the correct set of transformations. First one is reflect with respect to y-axis to 2 units to the right. And lastly, one down. Okay, so I hope you're getting the idea, but the questions can become hard. So you need to just keep on the track, remember all these things in the summary, okay, and keep in mind the order should be this. Okay, and let's see how we do the last one. Well, the last one looks very complicated. So let's start with one and do a series of transformations one at a time. Okay, so fx and reflections. I can see two negative signs here and here. This negative sign is outside the function. This is inside. Okay, so reflections can be done in either order. I would pick the outside one and then the inside one. When you do the inside one, use that safe bracket. Okay, so fx, and then you have negative of fx, and then you have negative of f of negative safe bracket x. Okay, so with that I did two transformations, so two reflections. So I did both reflections, and then you can see there's a horizontal shift. Now the horizontal shift is 2 units. Okay, and I see a +2, so that's like the previous question. I see a +2. If I need to put something here that gives me +2, that should be -2. Okay, so that's why I put f of negative, well, there's this negative here, safe bracket x minus 2. Okay, now you can see that this is the same as f of negative x plus 2, which is the same as negative of f of 2 minus x. Okay, now we can just do the horizontal compression, and that would be just do 2x. So whenever you see x, you would put 2x, and that would give me, so now I'm using this function because that's what makes more sense, and plug in 2x, which means you would put 2x here. So f of negative f of 2 minus 2x, and lastly add 5. which is the same as I just did it add 5, so that's that. So that's what that's the function we need. Okay, so let's see what those transformations are. So the first one is a reflection with respect to y-axis. Well, reflection with respect to x-axis, reflect with respect to x, and then reflect with respect to y. Okay, and then now you can see -2, that's right 2, and then you can see horizontal compression, by 2, and then up 5. So the transformations in order to get this function would be reflect with respect to x, reflect with respect to y, right 2, and then horizontal compression by a factor of 2, and lastly up 5. Okay, so I believe right now at this point I've done enough examples for you to do a question. So do this question on the screen, and we'll move to the next question. All right. Okay, it was an easier question compared to what we did. Well, let me just do that. Fx, f of x minus 1, f of x minus 1 plus 1. So that's right 1, and this is up 1. Okay, all right, let's move on. So sketch this graph of this particular function. So you understand that the parent function is x cubed, and the function x cubed, as you might have remember, if you don't, you can you can recall that when I draw it, has 0 0 at this point, and it looks like that. So let's see how the transformations are done. Okay, so it's a little long, so let's see. I start with x cubed. Okay, I can see a negative sign there, so I would do negative x cubed. That's a reflection, and I put the negative in front of the function, which means it's a reflection with respect to x-axis. With respect to x-axis. So let's just draw the function as well. You had this guy, and you reflect with respect to x-axis, you have this guy. Okay, and then now that doesn't really affect because you put the negative sign in front of it. So the next one would be shifting, and that would be x minus 3 cubed. And remember, this negative sign was outside, so that is not a really big issue now. But this is right 3. You can stop the video, think about things, and then come back. So right 3. So now that this point 0 0 here moved right 3, so that would be 3 0. Okay, now the next one would be that 1/2, this 1/2 right here. So negative 1/2 x minus 3 cubed. Now that would be a horizontal stretch. Okay, so horizontal, oh no, vertical, well, my bad, vertical, because you do it in front of the function, not in front of x, so it's vertical and it's a compression. So the function would become like this. Okay, it's very hard when you don't have a scale, but the function would look a little, you know, short. So that's why sometimes we ask you to draw 2 points on the graph so we can see how the other point is affected. But you know, let's not worry about it. We have enough things to remember. Okay, and then add 2. Negative 1/2 x minus 3 cubed plus 2, which is the same as my final function 2 minus 1/2 x minus 3 cubed. So that's my final function. Here you would go up 2 units. So you can see the graph would be go up 3 1 2 and then look like that. So what I expect, let's say this is an exam question, what I expect you to draw is a graph that would be, you have 1 2 3 and go up by 1 2 and right here, and it would look like this and this. And that might be the only thing. I would also like you to write down what this point is, and that's pretty much it. So right now the focus is not finding those intercepts, it's just the shape of the graph and one point it goes through. All right, so let's move on to these really nice examples of domains. Okay, let's think about this now. Just think of things in terms of transformations. Okay, so what does the so let's just do a transformation starting from fx, go to fx minus 1 and then go to fx minus 1 plus 3. Okay, how does this transformation work? Well, that's right 1 and up 3. Okay, so when you do right 1, you move the graph that direction 1 unit. So all the x values would be shifted by 1 unit. Okay, so that's what it means. So if x values will be shifted. Now think of the movement that's that way, which means the x value should be shifted plus 1, shifted by plus 1. Okay, that completes the sentence. All right, so if the original x value 2 would shift by 1, the original x value 6, the domain would shift by 1. So the new domain would be, in this stage, would be 3 and 7. Okay, now the domain, if you remember what the domain is the set of x values. Okay, so that's the set of x values where the function is defined. And all those x values shifted by 1 unit. Okay, and then that's a vertical translation, and vertical translation does not affect any x values, which means this doesn't affect. So it doesn't move, so the last so the domain would remain at 3 7. So let me just draw this and show you. Let's say you have this function and the function was something that has domain from 2 to 6. So when you do right translation by 1, it would be translated like this. Just take it up and move it by 1 unit. Now it would be moved to 3 to 7, and you can see it just moved that way, so the domain is this. Now if you move it up without moving it sideways, now you can slide only that way. Okay, so it would move up, but this domain will still be 3 7. Okay, so that's it. So with that, what you can think is, well, horizontal transformations, horizontal movements affect only the domain, and the vertical movements just affects the y values, or vertical movements affect only the range. So you don't have to do all the series of transformations. Just look at the function and think of what the vertical or the horizontal transformations are. Okay, so let's see what happens here. Okay, this is outside, and that's a flip with respect to x-axis. That's, you have the function like this, it would be like this. It's a vertical movement, it doesn't affect the domain, so we can just ignore that. Okay, now this though is a horizontal movement. This is a horizontal compression. By 2 units. So let's think about that. You had a function which had domain -2 to 3, let's say something like that. It would shrink horizontally. The domain would shrink by a factor of 2. Okay, so these numbers would remain the same, but it would just shrink like that. So, well, which means my domain, just the endpoints is divided by 2. So endpoints are divided by 2. So the new domain would be -2/2, 3/2, which is -1, 3/2. Okay, think about this. And also you should know that this lecture is just these examples might not be enough. You have to do examples by yourself and see how these things work. Okay, so you need to do homework, you need to do the WebAssign and see how these things apply. All right, let's move. So if the range of hx is 1 to 5, what's the range of 4 minus? Okay, now this looks bad, but let's do a series of transformations. So fx, reflection negative fx, horizontal transformation negative f of x minus 1, and then times 2, and then add 4. Okay, have a good look at there and see how I did those transformations. I followed exactly my order: reflections first, horizontal movements, and then compressions and stretches, and finally vertical movements. All right, so what affects the range? Now this is you had a function like this and it becomes something like this. Now that would affect the range. Okay, and this is one, right? And remember, horizontal movement doesn't affect the range, so range is not affected. and then you multiply by 2. Okay, and it's affect the range. Okay, and then you up 4. Okay, so what happens here? Times -1 times 2 add 4. So let's do that to the endpoint. So we had 1 5 times -1. So you have -1 and -5, but -5 comes first, so -5 -1. Remember, this is an interval. Okay, and then times 2, that would be -10 -2, and then plus 4, that would be -6 2. So what, how do you go from here to here? -5 times 2, -1 times 2. And how do you go from here to here? -10 plus 4, -2 plus 4. Okay, so the range of the function is -6 2. Oh well, there's a small typo here. What is the range of 2h x minus 1? This is given as hx. So everything should be h, but I don't think that matters. I would say this is f and this is f. So now everything is consistent. But what matters is you do the series of transformations and see how the vertical range is affected. All right, let's move on to a question. So answer the question on the screen, and then let's move. Okay. So I'm asking about the domain, so only the horizontal transformations affect. So the domain of fx is 1 5. So what's the domain of f of t 2x? You would just divide the endpoints by 2. This is a vertical transformation, so it does not matter, not affect. So just divide the endpoints by 2, so 1/2 5/2. And you might have the question, so in the previous question I multiplied things by 2. That was a transformation. When you had it outside you multiply, when you have it inside you divide. Okay, so just summarize all those things in your notes and you should be good. All right, let's move on. Okay, so draw the graph and then find the value. Well, you don't have to draw the graph to find the value. So let me show you how to find the value, and then let me also go to no. So let me just find the value, and the question I ask next is about finding this value. All right, so let's remember, you mark cases: case 1, case 2, and case 3, because the function is given as 3 different cases. Okay, so to find f of -3, you look at these. This is where you look at to see where they live in. Okay, so -3 lives in this interval. Okay, so this interval is -∞ to -2. This interval is -2 bracket to 2, and this interval is 2 to infinity. Okay, -2 lives, -3 lives in this interval, so lives in case 1, and -2 lives in case 2, and 5 lives in case 3. So now you just know where to plug in. So it lives in case 1, so plug into case 1. So f of -3 is -3 plus 2 squared plus 1, that is 1 plus 1. that's 2. F of negative 2, that's case 2, lives in case 2. Plug it in here. Absolute value of negative 2 minus 1, absolute value of negative 3, that's 3. F of 5, square root of 5 minus 1, because that's case 3. Okay, that would be square root of 4, that's 2. So f of negative 3 plus f of negative 2 plus f of 5 is 2 plus 3 plus 2 equals 7. So the idea is find which case the function, the value belongs to, and then plug it into the correct case. So just the complete idea here is plug into the correct case. Okay, now let's do the graphing part, because graphing part might be a little difficult to solve. So what you first need to do is just build a wall. Okay, so we are building now, there are 3 cases, so we are building 2 walls. So let's build the wall. The first wall would be negative 2, because x is less than negative 2, and there's this. Okay, and the second wall would be drawn at x equals 2. Now these walls are just guidelines for you to know when a certain function stops. Some functions should not go beyond the wall. Okay, so if something starts here, it doesn't go beyond this. There's a different case here, and there's a different case here. So case 1 lives here, case 2 lives here, and case 3 lives here. Okay, so let's completely draw this thing and see. Okay, now I will use some things we learned in this lecture without further mentioning it. Now x squared, this graph x plus 2 squared plus 1 is up, well, left 2 and up 1. So the graph on its entirety would look like left 2 and up 1, something like this. Okay, and this point is negative 1. Okay, that point is plus 1. Okay, so this point is negative 2 1. Okay, so that's the first case. The second case is absolute value function moved 1 unit to the right. So absolute value function is a v, and that v is moved 1 unit to the right, and you have that. And the third case is take the square root function and move it 1 unit to the right. Okay, well, let's draw things in different colors. So this one is in blue, and the last one is in green, and it's square root function 1 unit to the left. Okay, now let's see how my wall affects those types. So here, this is case 1, this is case 2, and this is case 3. So case 1 only lives in this part, so nothing here matters. Okay, so you can see there's a part of a parabola coming and hitting the wall. Case 2 lives between negative 2, and plus 2. So nothing here matters and nothing here matters. So it's a part of a V, not all of it. And the last one is case 3. It lives somewhere here. So this is 1, this is 2, nothing here matters. Okay, so now the only last thing we have to find is what happens at those points. Okay, one thing we know for sure is this point is -2, 1, and that's all. So let's combine all these three things here. Okay, so first one is that point is -2, 1, so -2, 1 and something like that. Okay, and then the middle part goes to 1 and probably in somewhere here, and like that. Well, it should be in blue, so let's draw in blue. And the last part is the square root function part. Now everything is good until we look at the function and look at this and see that this is not an open circle, not a solid circle, it's an open circle. Why? Because it says x is strictly less than 2. Now first, just see whether you understand everything else and then think about this. Okay, and then because you have less than or equal, that is case 2, this should be a solid dot. Okay, and lastly, this one right here, less than 2, so this end should be a open dot, and again x is greater than, just greater than, so again an open dot. So this is the final piecewise function you get: solid dot, open dot, open dot, open dot. Okay, so let's see whether the next question is on this one. So that's the end of the video. Once you finish it, you can the video is done. Just find the correct piece of this piecewise function. Do the question on the screen. Thank you. So I hope you got it right. If you can close the video if you want. So -4, so this interval is -∞ to -2, this interval is -2 to 2 bracket, and this interval is 2 to infinity. So -4 lives here, 2 lives here, and 3 lives here. So this is case 1, this is case 2, and this is case 3. So plug it in. So case 1, f of -4, case 1, -4 minus 1 squared plus 1, that is 5 squared plus 1, that is 26. Case 2, f of 2, that would be absolute value of 2 minus 1, absolute value 1, 1. And case 3, f of 3, that would be square root of 3 plus 1, square root of 4, that's 2. So 26 plus 1 plus 2, that's 29. Okay, thank you.